Okay, so on number 9 you had mass A, B, and C. And they're each 2 meters apart. Here was A, here was B, and here was C. So that distance from there to there is 2 meters, and from there to there is 2 meters. And I wanted to know the net force on A. So I know that B is pulling A to the right because it's gravitationally attracted, and C is pulling A to the right. So I'm looking at the force for B on A and the force of C on A. So big G, mass of A, mass of B, over their separation squared, plus big G, mass of A, mass of C, over their separation squared, should give me that net force. Well, I have 6.67 times 10 to the minus 11 Newton meter squared over kilogram squared. Units on every number, please. Mass of A was given to me as 10 kilograms. Mass of B was 18 kilograms. And they're separated by 2 meters, and I need to make sure that I square that. I'm going to do the same thing for C, A and C, so 6.67 times 10 to the negative 11th Newton meter squared over kilogram squared. Alright, the mass of C was given to me as 25 kilograms. Mass of A is still 10 kilograms. And they are separated by, alright, now from A to C it's actually 4 meters. So I did the math, and this one I got 3 times 10 to the minus 9 newtons. And over here I got 1.04 times 10 to the minus 9. Now I added them because B is pulling A in that direction and C is pulling A in that direction, so they're both to the right. When I added them, I got 4.04 times 10 to the minus 9 newtons to the right. Okay. Now I have to figure out what's happening to B. Well, B is being pulled in that direction by A and in that direction by C. So I said, well, the net force on B is equal to the force of A on B plus the force of C on B. We already know the force of A on B and the force of B on A. They're the same. It's just this will be to the left. So that's a negative 3 times 10 to the minus 9 newtons. Now I need to find the force that C exerts on B. So it's going to be the big G the mass of B was given to us as 18 kilograms. And then 25 kilograms. And they are separated by 2 meters. Don't forget to square it. So when I did that math, I got 7.5 times 10 to the minus 9 newtons. And it's positive because it's to the right. So when I added negative 3 times 10 to the minus 9 to positive 7.5 times 10 to the minus 9, I got 4.5 times 10 to the minus 9 newtons. And that was to the right because it was positive, and I said to the right was positive. Okay, last one, I need the net force on C. So net force on C. So I want the force of A on C plus the force of B on C. And I think I've already solved for those in the other problems. If you look at C is here, here's B, and here's A. C is being pulled to the left by A and being pulled to the left by B. So both of those will be negative. So when I did that, I got force of A on C I did in a previous problem was 1.04 times 10 to the minus 9 newtons. And then the force of B on C we just found a minute ago to be 7.5 times 10 to the minus 9 newtons. They're in the same direction. Both of them are to the negative direction. So when I added those, I got 8.54 times 10 to the minus 9 newtons. And then the direction is to the left. All right, I believe I'm done. Good luck. Please study.